Well.
I'll just watch.
Alright, so 99. Very strange looking thing. Sure, okay. So this has got a cylinder, it's got a height of 30 feet. It's number 99 in section 3.4. And they got a little hemisphere there, right? Half a sphere. So I don't know about you, whenever I get a new math book, you look in the front, you look in the back, just to see what the hell it tells you. So I don't know if anybody looked at the front and notices that it tells you a lot of geometrical things, like the volume of a sphere, in case you didn't know. What's the volume of a sphere? Let's think back to what Jeff just said. Jeff just told you where the answer was. And he's talking about himself in the third person. It's never a good sign. Hey! 4/3 pi r cubed. Cool. So I got half a sphere, so that's going to be half of that, which is it's not. Well,
Divide by
4/3 pi r cubed. Divided by 2 even better is 2/3 pi r cubed. Cool. So that's the volume of the top. What's the volume of the cylinder?
Pi r squared times height.
Beautiful. I love it. Because you got the circle is pi r squared area, and then you multiply it by the height, and then, so that gets the whole volume that it passes through. It's kind of a cool equation. So this guy is pi r squared h, where the height is 30. And you know the total volume is what?
15,000 feet cubed.
So you have this plus this equals that. Cool. Did whoever asked the question, did you get that far?
I don't know.
All right, there you go. That's where I'll stop then. I'll let you guys work on that from there. Yes, sir. And then there was another part of the question.
Well, he had like all the word problems.
Yeah, all the word problems.
Well, I'll get you started on that one. And then 102, we've seen a problem kind of like this. 100?
And 100, yeah.
The football field,
Oh, okay, let's see. 100.
or some kind of field.
A rectangular parcel of land has an area of 5,000 square feet.
And you get X and then
Measured to be 10 feet longer. Then one side of the parcel is the diagonal. This is X plus 10.
and it's 30 something hundred.
What are the dimensions of the land rounded to the nearest foot? Cool.
And it gives you the mine was different.
Oh, okay. But it's the same kind of idea, right?
Pythagorean theorem, right?
Good. Because to get the area of this guy, you need to know this dimension there, right? And the shape you make when you draw the diagonal and you make a right triangle.
Yeah.
Cool. So then you use Pythagorean theorem to figure out the last side. So then this times this will be equal to that. Yeah, so what would Pythagorean theorem say for this guy? Let's call this guy y.
It would say
X squared
X squared.
plus y squared equals x plus 10 squared.
Cool. Solve for y.
Minus x squared.
Yeah, alright, sweet. So y squared equals x squared, and x squared
Trick
cancels.
question.
Plus 20x plus 100.
yeah, definitely got there. Then square root both sides, right?
Square root, yeah. And you don't have to do the negative part because this is a
Area
Length.
is positive.
yeah. So then the area is 5,000 square feet, and that equals x times y. X times this. Yes.
I think I'm just thinking too hard. How did you get the 20x plus 100?
Oh yeah. Well, if you FOIL this out, you get x squared plus 20x plus 100, and then the x squared is canceled. Yeah. All right, that's as far as I'll take. I mean, where do you have to go from there? What do you have to do next? What do you have to do? Where's your variable that you're trying to solve for?
On that side.
Inside.
Part of it's outside, part of it's inside. So you got to free that dude up. So you have to do what?
We have to isolate it too. Right?
Square it. You can square it right now. You can leave stuff on the outside.
Why do you have the X out there?
Huh?
Why is the X out there?
Because the area is length times width. So
That's
length times width.
Okay.
Right? They told me the area's thing is 5,000, so the area is going to be this side times that side.
Oh, gotcha.
I mean, that makes sense too, making this feet square.
So since your variable, part of your variable is stuck inside of a square root, what do you have to do to both sides? You have to square it.
Mm-hmm.
And that's as far as I'll take it. You guys try to go from there. Yeah.
Oh, you still have one more question.
Oh, yeah. Alright, so there's 99 started off, there's 100 started off, right? And I mean, alright. Always the most important thing about any of this stuff is to not get bogged down in the specific problem itself. What was the thing that I did to solve this? Because I hadn't done this problem in forever, since I last assigned it, which was a long time ago when I first taught out of this book. So when I first started this problem, I had no idea I was going to end up here. So, I mean, what did I have to do? I did draw the picture, label what I didn't know. I know I need that for the area. So you got to see, what is it? How am I going to attack the problem? What is it that I do? They tell me area. I need to know that side. Do I know it? No. Shit. Okay, what do I know? How do they relate to what I need to know? Let's attack that first. That's Pythagorean theorem. It's a nice triangle, right? I've got to get that side, so I've got to do this. Once I got that side, why did I want that side? Oh, yeah, because it's in the area. Bam. Put it in the area, right? And now you start to see, well, what the equation has a radical in it. My variable's stuck. Got to free my variable up. So you got to see, what is it that I'm looking for? What's telling me what to do next? It's in the very first part, of course, is what do I not know that I need to know to go forward? I didn't know that side. So any specific word problem is nowhere near as important as what's the process you would use to attack it, right? So number 102. So let's see if you guys can use that process to attack this. And we've seen something like this. The gutter problem is sort of like this.
Yeah.
So 102, they start with this flat piece of cardboard. 20 by 40. So some of you guys probably remember some of that problem we did earlier with the gutter. Because now they're cutting out the sides of this so they can fold it up and make a little box out of it. Right? This is raining outside. The power went out. They're like, let's make boxes. I guess, I don't know. And of course, they tell me how big this little square piece is that I'm cutting off. It's X, right? So how long? So here I've got the little three-dimensional dude. I don't know, Jeff, you can do 3 dimensions right now, can you? Yay. All right. It's really good for me. All right. Don't push it, Jeff. All right. So what's the dimensions here, and what's the dimension there? I need all 3 for the volume. So again, what's holding me what to do? They gave me the picture. That's nice of them. So now I want to label that picture since it's got something visual. I know it's all about volume, so I know I need all 3 dimensions of this thing, right? So how wide is this? It used to be
20 minus 2x.
That's just like the gutter problem. So of course this is going to be
40 minus 2x.
and of course this is going to be
X.
Because that's where all the minus 2x's went to, was to give it height. Cool. So of course I can cut larger and larger squares. If I don't cut my square large enough, I've left a lot of material, but it's not going to be tall enough to hold much. If I cut it too much, I've cut off too much material, it's not going to hold as much. So there's some sweet spot in the middle. That sounds kind of parabolic, right? If I don't cut anything, the damn thing's flat. I'm going to pour stuff into it, it's not going to hold a damn thing, right? Hopefully it's not liquid, it's cardboard, it's not a good material. If I cut too much off, same kind of thing, it's not going to hold as much. So in the middle somewhere is going to be that maximum. What are they asking for?
15.
Then they even asked me, I'm thinking I'm a maximized problem. Here they told me I want the volume to be specifically something. So the volume of this is going to be what?
1,500.
1,500. Cool. And what's the volume from the picture?
What?
X times
40 minus 2x.
40 minus 2x times
20 minus 2x.
20 minus 2x equals 1,500. Don't you dare say x is 1,500 or 40 minus 2x is 1,500. right? Don't you dare do that. This problem is easy. No, not that easy anyway. So what do you have to do from here? This is as far as I'm going to go, but
4.
you got to multiply a sucker out because some person, and that's just the way the problem was, but this is supposed to be 0. If it was 0, it'd be awesome. I could figure it out, but it's 1,500. Got to multiply this back out, suck the 1,500 over, and then you have to refactor. And that's why it's in this section probably, because the factoring is going to take a little something extra. Yes, interpretation. One thing I want to tell you, notice this, because you're going to end up with some number that's got some big ass factors to it. How big could x be at most?
10, or not 10.
Yeah, 10 is like 10 with the parenthesis. Because if I cut squares of 10, I would basically not have a side anymore, right? I mean, so x has got to be less than 10. And obviously it's got to be greater than 0. So when I make my list of possible roots, I don't have to worry about anything that's over 10. My list is going to be naturally, physically smaller. There's physical limitations to it, not mathematical limitations, physical limitations to my x. I don't know if you guys are with me. You're going to get something you're going to factor synthetically, as somebody pointed out in a good tone.
Eventually you'll get to quadratic.
Could be. Yeah. Get too much away. Yes. Is that cool for that problem? Has anybody done that problem yet? Okay. Oh, good. All right. Sweet. Yes.
Well, I did the problem in 276, number 2. I just don't understand what it's asking.
Oh, okay. All right. It is a little too open, I think. So if I have some polynomial, blah, 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 right? X to the 5th, blah, blah, blah. And I get this to go in evenly, right? I get a 0. Are you guys decent with me just writing the outline of the idea? You guys kind of with me? If I get that to go in evenly, that means 2 things at least.
That's a factor.
And be a lot more specific. That's not a factor.
X
What's a factor? X minus 2 is a factor. And 2 is a 0. Or a root, or a x-intercept. There's a lot of different names for that same thing. You guys with me? So now this problem makes more sense. If a is a 0, if a was a 0 of the polynomial, then x minus a would have to be a factor of the polynomial. Sweet. Yeah.
Number 70, CMD for this section. 3.6.
Oh yeah. Sweet. Sorry. So 70C looks a little bit different. It's the first time we ever see a complex, an imaginary number specifically as a coefficient.
Which one is this?
This is section 3.6.
Oh, yeah.
Right?
Yeah.
Same section, yeah. Okay, but how do I do this? Now, in reality, when we proved the quadratic formula, x equals negative b plus blah, 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 these were then called real numbers, but it could be complex numbers too, and the formula wouldn't care. It would still work exactly the same way if these were complex numbers. So you're going to use this on that to solve it.
What about the I?
You throw it in. So what's A?
1.
1. What's B?
2i.
2i. Sweet. That's the number in front of the x. Right? I is a number. So it could be a coefficient itself. So I got 2 of them up there. And then C is negative 1. Plug and chug. See what the hell happens. You got to remember, what's I squared? Negative. What's going to happen somewhere in there? Yeah.
Can you do 3.6 number 10?
Number 10. The x to the 4th minus x squared, though. Are you guys cool with that? I mean, it's good old quadratic. Quadratic formula doesn't care if it's real or complex. You can just eat it up.
So you do that for both of them, huh?
For what?
C and D versions.
Yep. And D, A is I.
Right.
Okay. Where are we at? 10. Yeah, okay. So this one says, polynomial was given, find all zeros of P real and complex, factor P completely. So, I'll tell you, I'm going to tell on my Calc 2 students a little bit. I gave them a problem like this. You know, and this one might look kind of ugly because it's just no numbers, but if I told you factor, could you factor this?
Yeah.
Yeah, right? How would that factor?
2 and 1.
X squared.
2 and 1, and then of course you have to put...
X squared and X squared.
Alright, so a lot of them just looked at me like I was insane, and I'm like, you've got 2 students there, damn it. I got a little upset. But you guys, so that is a little bit weirder because the coefficients aren't immediately obvious, but you can totally factor that the same way we just did that.
2 and 1.
Yeah, 2 and 1 still. Which one's got to be negative?
2.
2. And x4 is?
X squared plus.
Now here's the cool part. Here's the part that's new for us. Is everybody with me? So higher degrees doesn't matter worth anything. How did I know, even though this is the 4th power, how did I know I could still do this? What's got to be true about the middle power versus the 1st power?
That they have to.
That's got to be half that. If that's not half of that, it's not going to be this easy. I got to use synthetic, or maybe it's not doable. You guys with me? The classic one has got x squared plus 4x plus 4. It's got 1 and 2. So as long as the middle dude is half the first dude's degree, it's got a chance. It's quadratic in form. All right, good. I want you guys at least looking at me. It's good. It's very important. But now we know we can go further. I can definitely go further here. Which one of these is going to involve complex and which one is not?
The positive is going to become...
Yeah, that's going to involve complex, right? And that's not, because it's minus, it's just going to involve irrationals. So this will be x minus rad 2, x plus rad 2. Because how do you factor difference of squares? You take the square root of each. If that was a 4, it'd be a 2 and a 2. That's a 2, it's a rad 2, rad 2.
Oh, yeah.
Because that's the square root of 2. You guys got it with me? So let that part be easy. We're extending it beyond whole numbers. We're in 176. We can handle stuff that's not whole. I can handle irrational stuff. And now we can handle complex. Cool. I like it. And then it says, so factor completely is part B. I love that. So like me, I ended up doing part B first so often. It was crazy. So we did part B first, and now part A is easy. Find all zeros. What are the zeros?
Square root of 2.
Square root of 2, plus or minus?
Plus or minus, and then plus or minus I.
Plus or minus I. Sweet. What is it about irrational roots and complex roots? Remind me, how must they show up? They always have
In pairs.
They have to show up in conjugate pairs. Have to. Have to. If the original, let me be really more general, considering that last problem we did. If the original coefficients are rational, these have to show up in conjugate pairs. Right? So if I have a normal factoring problem, any irrational or complex roots have to show up in pairs, plus or minus is involved. You guys, because it would come from the quadratic formula or from the fact that they're going to split this in 2, so if you're going to get a radical there possibly, right?
Mm-hmm.
Okay, maybe.
Well, can't you just say that it's to the 4th root, so it should have?
It's got to have 4 answers, but they show up specifically as pairs, conjugate pairs. Good. How are we doing so far? You guys are like, oh, I'm so happy it's Monday again. Here we go. All right. Okay. That problem did not say use synthetic division. So if I just give you a problem, I say factor this or find all the zeros, and it's factorable, like you don't have to use synthetic, don't use synthetic. There's no need for it, right? Group it. Try something real quick first. Rule out the easy stuff before you start doing the weird new stuff. Okay. Anything else from homework before one last thing maybe I'll take. Okay, cool. So what I want to do is I want to let you guys work and let me shut up. Not this problem yet. This problem. So we're going to do what we did last time, but we're going to take it one step further. So, first thing I want you to do is list all possible rational roots. Pay attention to the 4 out there, right? Hint, hint. Part B, I want you to tell me what Descartes would say about this. No. His rule of science. Not his opinion about the problem, this is rule of science. Got your books. This is open book. This is not a test. You can kind of remind yourself of what the hell it is if you forgot. Part C, I want you to divide by 2 synthetically. So divide by x minus 2. So synthetically divide by 2. And tell me what your result means.
Is this 3, 7, or 3, 6?
This is still 3, 6. Which is really 3, 4, and 3, 3, and 3, 2 combined. So divide by that, tell me what it means. Synthetically, right? Don't do any long division, correct? Synthetically. Part D, update the list. Find all zeros. Alright, so this is basically a review of everything we've done. It's a review of chapter 3 that we've done so far. So you guys can team up.